Let's talk about programming. You've signed up for a degree that involves doing programming, so it's probably a good idea to start by making sure that we understand what it involves. So this dictionary definition at the top says that programming is the process of writing computer programs. To me, that's not particularly helpful. It's like saying that baking is the process of making baked goods, which is technically correct, but it doesn't actually get us any closer to discovering precisely what's involved in programming. So let's try to come up with a rather more helpful definition. So here I've called programming the translation of an idea or an algorithm into a set of instructions phrased in a specific programming language. In this case, our language is processing, which is a variant of Java. So programming, to me, is the process of converting an idea into a Java or a processing program, as well as everything else that's involved, such as testing, debugging, and so on. Now, the important thing about this definition is that it doesn't just focus on the program, which the dictionary definition did. It focuses on both the idea, or the algorithm, and the program. And as we'll see, both of these things, the idea and the program, are as important as each other in the context of programming. So, before we get into detail, I just want to address some of the long-standing myths about programming. That it's hard, that it requires a lot of maths, that it's the preserve of nerdy boys, that it's just about hacking out code, and that in order to be a successful programmer at university, you need to know how to do it already. Well, firstly, it's hard. Well, yes, it can be challenging, and that's why it's worthwhile. That's not the same as it being inherently hard. Programming is actually extremely logical, so if you take the time to learn the fundamental principles and take the time to apply them with exercises and so on, then it can actually be quite straightforward. And that leads quite nicely onto the second point about maths. For general purpose programming, the maths required certainly doesn't go beyond basic GCSE. So we might use, for example, the Cartesian coordinate system and Boolean logic. Unless you're actually doing some, say, heavy duty data analysis, which requires a lot of stats or complex graphics, you won't need to use any hard maths. You just need the ability to think logically. So the next myth concerns the stereotype that it's just for nerdy men. Well, many women actually achieved firsts in programming in terms of the historical development of the field. In fact, the first ever programmer was a woman, Ada Lovelace. And there are many other examples. Admiral Grace Hopper, for example, who wrote the first ever compiler. Your gender doesn't determine whether or not you'll be a successful programmer. The penultimate myth is that programming equals coding. No. We should only write code once we know what it is we want to do, what we want to achieve, and we can't do that without first planning everything out. And the number one mistake made by rookie programmers is to dive straight into trying to write code without first having a clear idea of what it is that you're trying to achieve. If you don't even know what you're trying to do, you're unlikely to succeed in building anything useful. And the final myth is that to succeed at programming, you need to know how to program. Well, everyone has to start somewhere, and we don't assume on this course that you know anything about programming before you start. In fact, self-taught programmers have often learned bad habits, and it's unlikely that anyone has encountered university-level programming methodologies before. So please, don't feel intimidated if you've never programmed before, and don't make the mistake of measuring your own progress against anyone else. So one of my hobbies is running, and it makes me happy. But if I thought it was useful to compare my own running times against those of younger, fitter runners, or those that had more natural talent than me, then I would just quit. I run for myself, and I measure my progress in terms of how I perform compared to how I did last week or last month. So you should only measure your progress in programming against where you were when you began your journey. Ignore everyone else. That's not to say that other people can't help you to get better, but don't make the mistake of comparing yourself to them.